So what are dust devils? Well, on Earth, dust devils are low pressure and small, and that means many to tens of meters, convective vortices that are powered by surface heating and made visible by the dust they lift. And so these start at the surface and then they grow up into the atmosphere. And that makes them distinct from, say, a tornado, which, although it tends to form over land, it actually starts up in the atmosphere and it descends down to the surface. So this is a dust devil on Earth. And on Mars, the same sizes of dust devils on Earth do occur. And so this is one that we actually captured very recently with Curiosity, and it's probably about 5 meters across. But they can also be hundreds of meters across on Mars and several kilometers tall. And you can see this because this is an image of a dust devil that can actually be seen from Mars orbit, and it's over 100 meters across. And this cartoon here gives a sense of scale. So you can see Earth dust devils relative to tornadoes, and then Mars dust devils being a lot bigger. And by comparison, you can see the Himalayas, and then Olympus Mons, which is the mountain on Mars that's 3 times larger than the tallest mountain on Earth. So dust devils on Mars leave their mark all over the surface. And this is a really nice image showing some dust devil tracks. And again, this gives you a sense of the scale of dust devils. You can see where 500 meters is. So each one of these tracks is over, well, many of the tracks at least, not all of them, but many are over 100 meters across. And what happens here is that the dust devil is removing bright surface dust from the underlying dark surface, whether the dark surface is sand or it's just bedrock. And then by removing that bright dust, you can see it as a dust devil track as those dust devils pass on through. And here are some more images of dust devils and also lots of beautiful tracks. And you can see these dust devils caught in the act of making a track in all of these cases, and also casting shadows in many cases as well. So I love these images of dust devils on Earth, and I'll let the movies play a couple of times so you can see them. This one over here on the top right, where the dust devil is actually able to pick up furniture and toss it around, is really cool. The one down the bottom is very cool too, but I have to admit my particular favorite is the one on the top on the left with the dog who manages to bat it out. Yeah, there it goes. Oh, wait, it's back. Oh no, there it is. Oh, and you can see there's obviously a vortex that is continuing to exist, but the dog is preventing it from sort of touching down to the surface at a particular time, and so it can't lift up the dust while the dog's in the way. But then it's still there, it's still kicking. And here is a movie that I actually took myself in Oregon many years ago. And it was, I guess, a wheat field devil with the chaff or whatever on the top of the field. And it produced all these amazing visible vortices that I was very excited to see because I'd been studying Mars for a while by then. I'd never actually seen a dust devil on Earth. So keep a lookout anytime you're driving past a field that's just been dealt with, because you can often see these little loose particles on the top being blown around by these vortices if the conditions are right. So what are the right conditions for these things to form? Well, you have to look at how convective vortices form, because a dust devil is just a convective vortex that's made visible by sucking dust up into it. So you can have one start with opposing warm and cold winds. And this can be when, say, you have a very different surface properties right next to each other. So on Earth, maybe a field that's been cleared of vegetation right next to grassland, for example. And these can pass over each other, the warm over the cold air, and create some turning and create a horizontal vortex. And then the rising warm air begins to lift that vortex. And as the vortex steepens, it kind of forms a loop, like an arch. So now this apex of this arch weakens as it rises higher and higher, and eventually it will break apart. So now you have two columns, two vortices. And what often happens then is that one of them will be stronger than the other, and the other one will decay, and so you'll only get one. But you do often also see these vortices and dust devils sort of in pairs as well. And so, as I said, you can often see these at the boundary between different types of surfaces. And then they form and then they blow across the whole field. And you can also simulate this in computer models. So this is, again, a large eddy simulation, and you can see these vortices developing, and in each case you can see the middle of the vortex as a pressure drop, and that's how you can, and because you have the air coming up and out at high levels, and so that removes some air from the column, and so that's why you get a pressure drop at the surface where these vortices sit. And this is a surface pressure map that shows that each one of these really dark colors, these dark blues and purples, show a different vortex. And overall, all the other patterns you can see are just cellular convection, but you can see the dust devils showing up in the pressure maps. And this is a lovely simulation of dust devils where they basically allowed vortices to form in the simulation, and then they allowed them to lift dust when the winds around the vortex exceeded some threshold wind stress. And so you can see how beautifully that reproduces what you see in a lot of real dust devils, where this dust is being pulled up by the winds that are blasting around very quickly around that vortex, around that central pressure drop, and really causing a load of dust lifting. And one of the questions is whether it's winds or the pressure drop that is responsible for the most dust lifting, or whether it's some combination of the two. And so anyway, these are some dust devils spotted by the Spirit rover in Columbia Hills, and you can see that there's a lot of activity here. And these are some pretty big dust devils. And we also see dust devils with Curiosity, and they tend to not be quite as visible, maybe because there isn't quite as much dust on the surface, or perhaps, and this is very likely, that they aren't as strong as well as the ones that we saw with Spirit. Unfortunately, we didn't have a pressure sensor on the Spirit rover, so we can't really tell what the relative strength of the vortices were, but we can certainly see the relative sizes. And so you might be finding it a little bit hard to see this, so I'm going to show you a processed image here that shows now, it sort of tried to subtract off some of the background that doesn't change between the two images. And so now you can see that dust devil a lot more clearly as it just ambles along in the hills behind Mount Sharp. And the whole time of this video, by the way, is about 5 minutes. So Dragonfly, this amazing rotorcraft, is going to be going to Titan in the 2030s. And the question is, could Dragonfly see dust devils on Titan, even though Titan is so much further away from the sun and so gets so much less heating? And the answer is, maybe it could.